There we go. Okay, so who's gone today? Nobody in here? Hannah Kingstrom is gone today. I know that. Yep, she's gone. So, hi, Hannah. Carissa? Carissa D is here. Hi. Hi from Carissa D and from me. Hi, Hannah. All right. Yeah, whatever. From Carissa D, hi, Hannah. You got to figure it out. Okay, long division. So the basic problem, okay? We're going to test your knowledge of fractions today, okay? X plus 2 goes into 3x plus 6. The way you do these problems, you always ask, what do I multiply x by to get 3x? What do you multiply the first term of the outside to get the first term of the inside? 3. 3 is a constant, so does it go above the 3x or the 6? It goes above the 6, so 3 right there. After I get that 3, I multiply it back through. 3 times x, 3 times 2, and I subtract. When you subtract, you get 0, no remainder, okay? Divides evenly, I get 3. Any questions how I did that? Try one slightly more difficult. What do you notice about this one that makes it a little bit tricky? 0x squared. If you don't see an x squared, you have to put one in there. You have to insert a placeholder. So there's no x squared in there. You have to insert the 0x squared. Now I know everybody's done this before because it's part of your regular and honors Algebra 2 courses. This should be a little bit of a refresher. I start the same. What do you multiply x by to get x to the third? X squared. So that goes above the x squared. See, if we went to put that 0x squared there, where would it have gone? All right. Well, if we're going to be that way, Carissa D. And Chris is mouthing off to us right now. All right. I multiply that back through. I get x to the third minus 2x squared. And I subtract. What's x to the third minus x to the third? 0. What's 0x squared minus negative 2x squared? Positive 2x squared. Now, since you have an x minus 2 here, so it's a 0x squared minus a negative 2x squared. Since I have a binomial here, I have to have a binomial here. So I need to drop down my minus 6x. That way I have a binomial. What do you multiply x by to get 2x squared? 2x. Run the 2x through. 2x squared minus 4x. 2x squared minus 2x squared. Negative 6x minus negative 4x. Negative 2x. I get negative 2x plus 4. What do you multiply x by to get negative 2x? Negative 2. Run that through, you get negative 2x plus 4. Subtract those and you get 0. No remainder. Pretty cool? Yes. Nope. Any questions on that problem? Okay, let's try one that's a little bit more difficult. Have to put in my 0x. Oh boy. What do I multiply 2x by to get x to the third? 1/2 x squared. How do you like that? 1/2 x squared. How come? So the idea is you got to multiply 2 by something to get 1, right? So I set up the equation. 2 times something is equal to 1. Divide both sides by 2, and you get 1/2. So 1/2 is what we multiply to get that number. So we've got our 1/2 x squared. Multiply the 1/2 through. 1/2 x squared times 2x, x to the third. Plus 1/2 x squared. And I will subtract those. X to the third minus x to the third, 0. 4x squared minus 1/2 x squared. 3.5x squared, which is 7/2 x squared. Now let's see who can get this. This is a little bit more challenging. What do you multiply 2 by to get 7/2? If you don't know, set up the equation. 2 times something is equal to 7/2. How do you solve that? Divide by 2 or multiply by 1/2. You get x is 7/4. So we multiply by 7/4 x. Two x times 7/4 x is 7/2 x squared. 7/4 x times 1, 7/4 x. Seven halves x squared minus 7/2 x squared. 0. 0 minus 7/4 x. Negative 7/4 x. I drop down the minus 2. Now we ask the question, what do you multiply 2x by to get negative 7/4? If you don't know it, set up the equation. 2 times something is equal to negative 7/4. Divide by 2 or multiply by 1/2. X is negative 7/8. Hey there. Multiply by negative 7/8. Negative 7/8 times 2x is negative 7/4 x. And negative 7/8 times 1, negative 7/8. So we're almost done. Negative 7/4 x minus negative 7/4 x is 0. Negative 2 minus negative 7/8. Negative 2 minus negative 7/8, very good, is going to be, add the opposite. So negative 16/8 plus 7/8 is a remainder of negative 9/8. I don't have problems for you that fractions like that. But the book does, and you should be prepared for it. I know fractions are a stretch, but right now, if we're in college, algebra fractions should be something we mastered. So, okay. I want you to try D on your own. D on your own. This one works out pretty well. I think you'll like how it works out. Nothing funky about this one. Give it a shot. Remember to insert your placeholders, your 0x to the third and your 0x. Question? I'm sorry, so the ending, I'll talk about the ending. The rest of it you should have, but the ending may look a little bit weird. And I'll show you why it looks weird to you. If you took 8 and divided by 3, and you wrote that as a mixed number, you would get 2 with a remainder of 3. I'm sorry, 2 with a remainder of 2, correct? And you would write that as 2 and 2/3. Or 2 plus 2/3. Notice what you have here. This is your quotient. That's the result when you divide something. The 2 is your remainder, and the 3 is your original divisor. Well, look at what I have here. I have my quotient, I have my remainder, and I have my divisor. Now, you can write remainder -1, and I'll give you credit. But the back of the book is going to write it like this. And this is the way I will always write it. This is useful to us in the future. So you can either write remainder -1, or you can write it like that, but that is the terminology that I'll use. Any questions? Okay, let's do synthetic division then. Why do law and division if you can just do synthetic division? There are times in mathematics where you have to be able to do synthetic division. Or I'm sorry, law and division as well. Synthetic division goes like this. What number would give you 0 right here? 1. That's the number we put in this little box right there. Then we list off the coefficients of the polynomial. 1, -4, 2, and 1. I draw a line underneath, and I put another box there. That's for my remainder. Here's how synthetic division starts. We take the 1 and drop it down. Then you take the number in the corner, or 1, and you multiply it by that. What's 1 times 1? And you put it here. Instead of subtracting, you add. What's -4 plus 1? -3. 1 times -3? 2 plus -3? 1 times -1? 1 plus -1? So, when you're wondering what these represent, these are your coefficients. 0 is your remainder, and I work backwards. That means my constant coefficient is -1. That means my x coefficient is -3, and that means my x squared coefficient is 1. So the final result is x squared minus 3x minus 1. That's the result. That's the result. What do you think? You remember this? Let's set up the next one. What number gives you 0 right here? -2. That goes in the box. List off your coefficients. 4, 8, then what? 0, or -7. I don't have an x squared, so I have to insert my 0. Draw my line. Box. That's my remainder. Drop down a 4. That's how you always start. Now, it's multiply and add. Multiply and add. -2 times 4 is? Add 0. -2 times 0, add. -2 times 0, add. We get 4. -2 times 4 is -8. Add, and we get -15. Again, the way that you write this is your remainder is -15. That means 4 is your constant. 0 is the coefficient in front of x. 0 is in front of x squared. And 4 is in front of x to the third. So the end result is 4x to the third plus 4 minus 15 over my divisor of x plus 2. Question? Once again, you can write the remainder as -15. You just write r is -15. That's fine. But that's the way I always write it. And you need. So if I wouldn't show you that, then you would get to the back of the book and you'd see it and you'd be like, well, I don't get how they get that. Well, now you see. So that's how they have it. I'll accept -15 as a remainder, but that's the way they write it. Yes, Chris D. like this part here, minus right here. So a negative 15 is the same as a minus, same as subtraction. You could write it as plus negative 15 if you want. Yep, if it was positive 15, we write plus 15. Good questions. We'll do C together. You can try D on your own. What number gives you 0 right here? 1/4. List my coefficients. 4, negative 8, 12, 3. Drop down the 4. What's 4 times a fourth? Negative 8 plus 1. A fourth times negative 7. Negative 7 over 4. Ooh boy, now I have to add 12 and negative 7 fourths. That means I need common denominators. How can you rewrite 12 as a fraction? 48 fourths. So 48 fourths plus negative 7 fourths is 41 over 4. 1/4 times 41 over 4 is 41 over 16. Now I got to rewrite 3 as fourths, so, or as sixteenths, excuse me. That's 48 sixteenths. 48 sixteenths plus 41 sixteenths. 89 sixteenths. My remainder, constant x squared. So my final answer is 4x squared minus 7x, 41 fourths, 89 sixteenths over 4x minus 1. Can't have a fraction in the top, but we'll just leave it right now. Technically, you should multiply by the reciprocal of the bottom, so you just have one fraction. So, kind of a minor point at this part. If you try D on your own, notice they're out of order. You got the 6 first, so place them in the correct order and see if you can just D on your own. Should work out pretty nice. Is that what you got? Awesome. So we're good to go. We can leave division behind. So I will not put long division on your assignment, but you will have to do a couple long division problems on your study guide, okay? All right, so we'll get back and review it at that point. When we get back from break as well, from Thanksgiving break, we'll do a couple long division problems just to refresh your memory in checkpoint quizzes and stuff like that. So. All right, let's move on to the next piece then. What we want to talk about now is the rational roots theorem. It's the whole reason why we do division, okay? So here's the question. True or false? You guys know how to graph polynomials now. True, you graphed them yesterday. But they were all in factored form, weren't they? And if they weren't in factored form, you knew generally the factoring methods to use. The question is, what if they don't factor in a way that you understand? Like, look at problem 1 here. X to the third minus 7x minus 6. If this was an x squared and it was a positive 6, you would say I could factor that. But right now, It's pretty tough to factor that. I could show you how to factor that. And I could show you how to do it pretty quickly. But it involves the rational roots theorem. Now, before we show you the rational roots theorem, let's just talk about the name. What does the term rational mean? Terminates if you were to write it out as a decimal, so that means that it can be expressed as a fraction. The root word of rational is ratio, right? So if there are roots or solutions to these polynomials, they can all be written as fractions, okay? Now, we all know that sometimes you can come up with imaginary numbers, right? Sometimes you come up with square root of 2, stuff like that. You got to use a quadratic formula. But if there are rational numbers, they can all be expressed as fractions. And so the rational roots theorem says, hey, if there's rational solutions, we got a general way of trying to figure out what they are. And it's pretty helpful. Now, it looks kind of messy, but it's really not that bad. We'll simplify this real quick here. It says let p of x be a polynomial. So we're going to just talk about a polynomial of this form. And what this means is like a sub n, that's the front coefficient. And then you got a sub n minus 1, so that's another coefficient. A sub n minus 2 is another coefficient. And you can see the powers here. X to the n, x to the n minus 1, x to the n minus 2. So our powers go down in descending order all the way until we get to where we have just a constant without any x term. So this is just a fancy way of writing something that looks like this. P of x equals, say, 9x to the 4th plus 3x, or minus 3x cubed plus 4x squared minus 8x plus 1, okay? So any polynomial that looks like that, okay? It could be to the 40th power, could be to the 20th power, could be to the first power, it doesn't really matter, as long as it's of that form. We say that this front term right here has factors of q. We say that the last term, the constant, has factors of p. If it has any roots that are rational, if there's any roots that are rational, then they're of the form plus or minus p over q. Yeah, you could read it, but it's like, what does it mean? Let's show you. We'll set it up. A little graphic organizer here for you. First of all, what degree is the polynomial? 3. P's are factors of the last one. Okay? What are factors of 6? 1, 2, 3, 6. Q's are factors of the front coefficient. What are factors of 1? 1. My choices are my P's divided by my Q's. Well, the Q's are just 1, so that's pretty easy. And it's plus or minus. So we got plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, and plus or minus 6 over 1. Well, how could I check to see if one of them is a solution? We got even a better option than long division or synthetic division. Just plug it in. If it's a solution, it should be equal to 0. Let's plug them in. Let's try 1. That's an easy number to start with, right? What's 1 to the 3rd? 7 times 1 is 7. So I get 1 minus 7 minus 6 is negative 12. So was 1 a solution? No! Would be another good number to try. How about negative 1? Sounds good. So negative 1 to the 3rd is negative 1. Negative 7 times negative 1 is positive 7 minus 6. What does that give you? 0. So we found one that works. What worked? Negative 1. So if negative 1 worked, can you name the binomial that's a factor? x plus 1. X plus 1 is a factor. This thing right here, this polynomial, divides evenly by x plus 1. So what we're going to do is we're going to take this polynomial and we'll divide it by x plus 1 to see what the result is. And that will help us factor it. And I will divide it by using synthetic division. What number do I plug in up here? -1. What are my coefficients? I got 1, 0, -7, -6. I go through my synthetic division process. I bring down the 1. -1 times 1 is +0. -1 times -1 is 1. +7, or -7 is -6. Times -1 is 6. Add, I get 0. You should always get 0 for the remainder with your synthetic division when you do that. If you don't get 0, you did a mistake. You made a mistake, go back and check your work. So that means that I have x squared minus x minus 6 times x plus 1. So right away, I asked you the question, does that original polynomial factor? And it sure didn't look like it factored. But it does. It factors to that. Does x squared minus x minus 6 factor? Yeah. To x minus 3, x plus 2, x plus 1. So that polynomial factors to those 3 parts. So what are my, it's degree 3, so we know it has 3 solutions. What are the 3 solutions? And what do you know? Those are all rational, aren't they? Aren't they all part of my choices too? They are. Preston is in awe right now. You're not, okay, you're really not. All right. That kind of hurt my feelings then. Do you mean to say that I think the rational roots theorem is cooler than what you think it is? A little bit? Well, okay, just a little bit. All right, okay. I wonder my daughter someday, when she's seeing the rational roots theorem, will she jump for joy or will she scream in terror? What do you think? You think she'll scream? Oh, I hope not. I hope she'll say, Daddy, that's the most beautiful thing I've ever seen in my life. Well, maybe not. I mean, that would be kind of sad if that was the most beautiful thing she's ever seen. Let's try another one. I just think it's amazing. I absolutely love it. I love how simplistic it is. What's the degree of this one? 3. These are factors of the end. What are factors of the end? 1, 2, and 4. Q's are factors of the front. 1. My choices are my P's over my Q's. Got to find one that works, because I don't know how to factor that, and neither do you. What would you like to try? Try 1. 1 1/3 is 1. Plus 3 minus 4 is 0. So it worked. So what's a factor? If 1 worked, what's the binomial that's a factor? X minus 1 is my factor. So we'll reduce the degree of the polynomial to find other solutions by dividing it by the known factor, dividing it by x minus 1. And I can do that real quick by doing my handy-dandy synthetic division that you guys are now awesome at. I drop the 1 and I multiply. When I divide it, I got x squared plus 4x plus 4. Does x squared plus 4x plus 4 factor? To what? X plus 2 times x plus 2, or x plus 2 quantity squared. I'll write them both out so we all understand that we have a double root. You either have to state it's a double root or you have to list it twice. in order for it to count on my test. Let's graph it. I got solutions at -2, +1. Does this one end going up or end going down? It ends going up because it's positive. Since it's a third degree, does it start down then or start up? Starts down, finishes up. I have a double root at -2. Pass through. That's my shape. So already in 2 days, you guys, you're able to take this shape and graph it without many problems at all. Graphing's the easy part, right? We'll do 2 more problems. 2 more problems. We'll do 3, we'll skip 4, and we'll do 5. Actually, I don't think we have time to do 2. We're going to run out of time. Let's just go to 5. Okay. Degree. P's. 3, 4, 6, 8, 12, 16, 24, 48. Oh boy. Hey, could have been worse. It could have been the number like 256. How about Q's? 1. At least it's a 1. I mean, imagine if it was a 6 in front. Well, then we could divide us. No, we couldn't. All right, so your choices are going to be, and so this was Taylor Willis's idea. She did this, so okay. We'll accept it. I understand what we're saying. Why create more work, right? Let's conserve on lead. And paper. Well, the paper's already, I mean, it's not really, doesn't really, no, that was a bad thought. So, all right. So what do you want to plug in? Plug in, oh, you want to try 2? You want to jump right past 1 and go to 2. Somebody wanted to jump past 1 and 2 and go right to 3. I think we should just try 1. 1 plus 7 plus 8 minus 28 minus 48. Wait a minute. Scott looked at that already and he saw the minus 48 is just, too big along with the minus 28. It's just going to cancel everything else out. So you see how he saw right away that 1 would be a bad choice? Smart thinking. In fact, it's so far off that he probably saw that -1 would be a bad choice, but let's just see for sure. -1 to the 4th is 1. -1 to the 3rd is -1 times 7 is -7. -1 squared is 1 times 8 is 8 plus 28 minus 48. How about that? Does that give me 0? Nope, that doesn't give me 0 either. So, we will go to the number that Scott first recommended, which was the number 2, and 2 does work. Let's plug it in. 2 to the 4th. 16. 2 to the 3rd is 8 times 7 is 56. 2 squared is 4 times 8 is 28 times 2. Well, look at that. The 56's cancel, and then 16 and 32 make 48, which cancel with the -48, so it makes 0. So, which number worked? 2. So if 2 worked, what's the factor? X minus 2. So I put the 2 up here. 1, 7, 8, negative 28, negative 48. Box. Run through my synthetic division. Whoop. What do you notice about our result? There's a couple interesting things about it. Did you notice it's cubic instead of quadratic? Do you know how to factor it? You don't, so you got to do it again. Oh! Hey, I could have picked a 5th degree. It's 3rd degree, you got to factor it. Yeah. Oh, you could try to group, but it does not, it won't work with a grouping option. You can do your best, but I promise you, doesn't want to work. But let's think about it. We're going to be good about our guesses now, people. We're going to see something very obvious here. Number 1, when we plugged in 1, did it work the first time? So it ain't going to work the second time. We tried -1. Did -1 work? So don't try it again. Now look at this, you guys. Look at this. Do you notice something about all these values? They're all positive. So would it work to plug in a positive number? No. You need a negative result somewhere in order for things to cancel out. So no positive numbers work anymore in this. Don't plug in a positive result. So what would be the first option we should choose? Let's try it. -2 to the 3rd is -8. -2 squared is 4 times 9 is 36. -2 times 26 is -52. Plus 24. If you see, we get positive 60 and -60, and that will make 0. So if -2 worked, what's my factor? X plus 2. Let's do our synthetic division. Drop down the 1 and multiply. We get x squared plus 7x plus 12. Ooh, that's quadratic. Does that factor? It does. And so you can see this polynomial factors to x plus 3 times x plus 4 times x plus 2 times x minus 2. Factors to 4 pieces. We have 4 solutions. They are the solutions of -4, -3, -2, positive 2. And we could graph that in a jiffy because you learned how to do that just the other day. Isn't that great? That's the rational roots theorem, along with division. Extremely useful. If you know how to do this type of a problem, you got half the test right now. Okay? If you can work through the rational roots theorem and do that stuff, trust me, you're going to be in excellent shape. If you are you can't afford to put this off till past break. So I said you're not going to get a homework assignment tomorrow. If you do all this work tonight, then you don't have any work over break. If you don't get it done, this is what you have to work on. You want to do these problems out of your book. You also want to sketch a graph for each one so we don't lose that learning. Okay? You will not get another assignment tomorrow. But when we come back, I want this to be good, fresh in our brains. We will do just a little bit of review when we get back to make sure you're good to go. But the rational roots theorem, we're going to continue with it again on Monday because there's ways we can figure out how to make good guesses. And that's going to be a good guess option for us. Question, Emily. Oh, yes. So we're done. Yep. So when you see the roots, just quick sketch the graph. Okay. Yo. Yeah, I've got a bunch of them right over here. I ran a bunch off the other day.